In this video, we're going to illustrate how to do stacked column, pie, and scatter plots before you make your own plot. So here's some data from snowfall at Mammoth Mountain in California, great ski area. And we have snowfall for a number of different decades here. And we want to compare those in some kind of a easy to conceptualize way. So I'm going to click on first on year, which is A2, and then go over to I6, which is our last data set. Once again, say insert a chart, and it's going to give us a number of options. And this time we want to make a stacked column. So I can click on the type of charts. And this time I'm going to choose the stacked column chart. And what this allows us to do is to compare the year by year the snowfall for particular months. So we can see that January as a whole is definitely the biggest month, but not all years. So we can see here, like in 1992, it was smaller than February, and in 1980 it was smaller than February. So what we're looking at is the pattern of all of the years on particular months, and then the variability between those. So, for example, you see 1990, we see that there's virtually no snowfall in December, but in the 2000 there was a huge amount. So once again, we can look at this and say that the titles don't make sense. So I'm going to click over here and I want to edit the chart. So in this case, I'm going to customize the chart axes and titles. And I want to adjust that title to say snowfall snowfall patterns. Okay. So now the graph makes some sense, and we're ready to move on. Okay, in a pie chart is where you want to represent percentages of a whole. So, for example, here we have some data on the causes of death in California in the year 2000. And if you look at these here, we can see that, we see that heart disease is number one, then neoplasms, that's going to be different types of cancers and so forth, number two, and so forth. We want to see how does this vary as a whole. So this is just out of 100%. So if I take this section, omitting the title this time, and say insert a chart, now I want to put this as a pie chart, because as a pie chart, it's going to represent percentages as a whole. So now I can move this offside here. And you can see here that all of that information is now labeled. Once again, if you click on the ellipsis here and you say edit the chart, then you can customize, and you can customize, like for the pie chart, you can say that slice label, let's say we wanted to say value and percentage or something, and then the actual value would appear in those cells. So you can adjust various different aspects of the pie slice and so forth on there. But you can play around with that to get the idea. But the whole thing here is to represent out of 100%. So portions of a whole. When you go to scatter plot is actually the most common type of plot whenever you're doing any kind of experiment or any kind of investigation in science, where you have a continuously varying independent variable. And so right here, we're going to look at some data that was actually collected from some of my students. I asked them to look at their foot size and their height. All right. So we looked at their shoe size and then did a conversion into what their foot length would be for a particular size. And then they did their height. We want to see, what does this data look like? So here I'm going to highlight both of these things here. And then we're going to say insert the chart. In this case, what we're looking for is a scatter plot. A scatter plot is going to be representation of your X and Y data. And so insert chart scatter plot, and here we have the data. So if we look at this data here, this data, just to the untrained eye, this looks like, well, just a scatter. Well, part of the problem on this is that it starts at a very high value. It starts at 150. So everything is compressed between 150 and 200. And this is common when you do a numeric scale. So we want to adjust the axes here so that the lowest values are at the bottom, and we can expand up to 200. So let's go ahead and click on it again. And we're going to edit the chart. In this case, we want to look at the axes, so I'll customize right here. And we want to see the what's going on with the vertical axis. So here's the vertical axis. And here I want a minimum value. I'm going to put a minimum value of, let's say, 145. So notice that expands the data. It looks like we could actually go as far as 150. And now we can see that the data is very well distributed over the graph. I also want to see if there's any patterns, any trends. So I want to get what's called the best fit data. So I'm going to click under series here. And under series, I'm going to put in a trend line. I want to see a trend line. So the trend line is your best fit for the data, assuming that it's going to be of a particular type of a relationship. So that's linear. Here we have exponential. We can see logarithmic and so forth. Now, if you have a reason to believe that it's one of these, you might choose those, like a power series and so forth. I'm just going to choose linear because I don't really have any reason to suspect any other thing else. So if I wanted to show where, let's say, my shoe size was on this relative to my height, in other words, let's say that I want to illustrate my data point on this set, I can click on Format a Data Point right here. And once again, I can click on this and I can say, okay, what would be the value that I would choose? And that's probably more likely mine. And we're going to see where that is. And so I didn't change the color, so you won't see it appearing there. So again, I'm just going to go back on there. I will edit the chart once more. And again, what we're doing right here is we're doing a customization of a series feature. And what we're doing is we are looking at a data point. So here I'm going to choose the data point to be red. And now when we close this out, you'll see that point. So, so now we're looking at foot length versus height. And we kind of go, well, wait a minute. That shows that as my foot length increases, then probably my height increases. And again, that's pretty observable type of features that people who are taller tend to have larger feet. So this is a correlation, not a causation. Correlation means that there's a correlation between your height and your foot length. If you have longer feet, then you're more likely going to be a taller person. Once again, if I want to put this on its own plot to make it show up larger to my students, I'd say move to its own sheet. There's the same data. Again, my value right there relative to the rest of the student data. And now over here, you can put your own plot of your own data. Again, just make sure you represent the data first in some kind of column fashion like this, and then select whether you want stacked, pie, or scattered plot.